we want to find the eigenvalues for this matrix and then find out how these eigenvalues depend on our value of alpha. Okay, so let's say this is our matrix A. So if we want to find our eigenvalue, we want to solve the matrix equation AV is equal to lambda V, where lambda is our eigenvalue. All right, so let's write our equation like this. So instead of solving it like this, how we would usually do this is, and this happens either when our vector v is 0, but our vector v shouldn't be 0 if it's an eigenvector. So what that means is that this should be 0. And we can solve that by setting the determinant of this matrix to be 0. So how we can do this is do 3, 4, negative alpha, 2, minus lambda, lambda, 0, 0. So this is our a minus lambda I, which would be, we can, so now what we have to do is set the determinant of this to be equal to 0 and solve. Okay, so now we want to solve this for our values of our eigenvalue lambda based on our values of alpha. So if we use the quadratic formula here, so these are our values for lambda. So what that means is that based on our values of alpha, our values of lambda will be in different forms. If alpha is greater than 1/16, if alpha is equal to 1/16. We have three different solutions here. So if alpha is less than 1/16, what we get is this square root becomes still positive. So it's 5 plus or minus square root of something, who knows what, over 2. So we have, so let's take a look at the problem here. They want us to identify the eigenvalues of the matrix and then describe how the nature of these are. So these are eigenvalues, are two of them, and then this is what the nature of them are depending on the value of alpha.